Good day, everyone. Welcome to Tagum City National High School web course on Quarter 2 Force, Motion, and Energy. In this video, we will be looking into mirrors and lenses. We will be guided by our target learning competency, which is to predict the qualitative characteristics such as orientation, type, and magnification of images formed by plane and curved mirrors and lenses. We will also be applying ray diagramming techniques in describing these characteristics of the images formed by mirrors and lenses. We have learned from the previous videos that light is made up of different colors. The color of light is due to its wavelength or frequency. For example, the red color of light has a wavelength of 700 nanometers or nanometers. Light is also an electromagnetic wave which forms a tiny band in the electromagnetic spectrum. As a wave, light travels in a straight path, and its speed is constant in empty space, which is approximately 300 million meters per second. Light can behave like a particle too. Being a particle, it carries a quantum of energy. When light travels, it may encounter objects along its way. Three things usually happen when light hits an object. First is absorption. Light will be absorbed by the object. Second is reflection. Light may be reflected by the object which absorbed it. And third, light may pass through that object. Of the three mentioned, we will focus ourselves with reflection, which happens when there is a change in direction of a light ray. This usually happens when light rays strike or hit an object, such as the picture shown in this slide. There are two types of reflection. One is the regular reflection, and two is the diffuse reflection. Whenever a reflecting surface is smooth, light rays are reflected regularly. The reflection of light always follows the law of reflection, which says that the angle of incidence equals the angle of reflection. It is typical for regular reflection to form images of different objects. The reflections on still water are also an example of specular reflection or regular reflection. Perhaps the most common example of specular reflection is the plane mirror, shown in this photo. Now let us take a closer look into the law of reflection, which allows the formation of images or reflections. All objects in the universe are attributed with an imaginary line perpendicular to its surface, which we will call the normal line. In a mirror such as in this illustration, the normal line always intersects at right angles from its surface. Now let us assume that a light ray hits the mirror. This light ray, also called the incident ray, strikes the mirror at an angle from the normal. This measured angle from the normal is called the angle of incidence. Once the incident ray strikes the mirror, it is rebounded at an angle, which is known as the angle of reflection. If we will try to measure the angle of incidence and the angle of reflection, we would be surprised to find that they are equivalent, such as shown by this picture. Notice how the angles, the angle of incidence and reflection, are the same. The other type of reflection is called diffuse reflection. When rays of light are scattered at many angles rather than at just one angle, diffuse reflection occurs, such as illustrated by the picture on the right. This image shows diffuse reflection. It is typical that no clear image is formed by diffuse reflection. In the next video, we will explain how images are formed in mirrors and lenses. We will also look into curved mirrors and see how these images are formed by them. See you next time.